Grade 10 Mathematics. So week 4 is entitled Geometric Mean and the nth term of a geometric sequence. So by the way, I am Ronald C. Fernandez, your math teacher. So please prepare the following: your module 4, your notebook, your ball pen, and of course yourself. Okay, let's start. So for this video, so the learners will be able to, first, you have to determine the nth term of a geometric sequence and identify the geometric means given a sequence. Okay, so the formula for finding the nth term of a geometric sequence is given by a sub n. Okay, this is our formula. A sub n is equal to a sub 1 r to the power of n minus 1. Okay, where a sub 1 is the first term, a sub n is the nth term, and our r is the common ratio. Okay, so let's apply the formula to our examples. So we have two examples. First, given the geometric sequence, okay, 2, negative 6, 18, find a sub 5. Okay, so again, what's the formula in finding the nth term of a geometric sequence? So to answer number 1, so the formula is a sub n is equal to a sub 1 times r to the power of n minus 1. Okay, the given sequence, we have 2, negative 6, 18, and so on. Okay, so we need to find the a sub 5. Okay, so that's the unknown. So therefore, our a sub 1, or the first term, is 2. Right? Okay, this is the first term. Then our r here is, what is our r? So to get the r, that is just second term, or second term divide first term. Okay, so that is our second term is negative 6 over 2, or a sub 1, that is r is negative 3. Again, negative number divide a positive number is negative. So by let's substitute. So we need to find the a sub 5. A sub 1 is 2 times our r is negative 3 raised to, what is our n? Our n here is 5, since we need to find the a sub 5. So n is 5. This 5 minus 1. So this 2 times negative 3 raised to, what is 5 minus 1? That is 4. Okay. Again, PEMDAS rule, we need to operate first the exponent. So what is negative 3 raised to 4? Okay, very good. That is positive 81. So our a sub 5 is 81 times 2. That is 162. Very good. So this is our a sub 5, or the fifth term of the geometric sequence. Again, class, a sub negative 3 raised to 4 is, that is negative 3 times negative 3 times negative 3 times negative 3. Yeah? Again, delete na siya, negative 3 times 4, but you have to multiply negative 3 4 times by itself, no? So that is positive 81. This is positive. Negative times negative is positive, times negative is negative, times negative, that is positive. So our fifth term of the sequence is 162. Okay, so let's proceed to our second example. So again, this is the formula. So our sequence, okay, 150 and 25 and so on. Okay, so we need to find a sub 6. So a sub 6, that is the unknown. Then our a sub 1 is 100. Our n is 6, since find the sixth term. Then our R, that is 50 divide 100. What is 50 divide 100? Okay, very good. That is 1 half. No? Again, basin mo 2 ha. Again, this 50 over 100, you have to reduce that. That is equivalent to 1 half. So, let's substitute. Let's substitute, no? That is A sub 6. A sub 1 is 100. Raised to, 100 times 1 half. Raised to 6 minus 1. Okay, that is 100. Okay, 1 half. What is 6 minus 1? That is 5. So that is 100. What is 1 half raised to 5? That is 1 raised to 5. That is 1. Tama? 1 times 1 times 1 times 1 times 1 is 1. Over 2 raised to 5. Or 2 times 2 times 2 times 2 up to, okay, 2 raised to 5 is, that is 32. Okay, so this is 100 times 1 over 32. That is 100 times 1. That is 100 over 32. Or, that is, you have to reduce that by, okay, by 4. Now, divide by 4. Divide by 4. So, that is 25 over 8. So, therefore, again, this is 25 over 8, huh? Our sixth term of the sequence is 25 over 8. Okay? Next, number 3. Find the common ratio of the geometric sequence whose a sub 1 equals 4 and a sub 5 equals 2,500. Okay? Let's apply lang the formula. So we need to find the common ratio or our R. So a sub n equals a sub 1 times r to the power of n minus 1. So our a sub 5 are we'll have to give it now. A sub 5 is 2,500. Our a sub 1 is 4. So this is our last term, no? We will consider this as our last term. So a sub n or a sub 5 equals a sub 1. So therefore, our n here is, very good, 5. Okay. So r to the power of n minus 1. So a sub 5 is 2,500 equals a sub 1 is 4. Okay, 4. R. N is 5 minus 1. So this is 2,500 equals 4 times r to the power of 4. Okay. So what should we do? How to eliminate 4 here? So we need to divide both sides by 4. Very good. So 4. So r to the power of 4 is, what is r to the power of 4? That is 625. So we need to find r, no? R lang. Here is r to the power of 4. Okay? So unsa to buhaton nga nung to get r? Okay, so very good. We need to find the fourth root, no? Fourth root of 625. So r is, okay, so you need to find a number na if you're going to multiply 4 times by itself, no, the result is 625. Again, if we're going to multiply 4 times by itself, meaning multiply niya nimo siya ikaupat sa iyang kaugalingon, the result is 625. Okay, very good, no? It should be 5, right? 5 times 5 times 5 times 5 is 625. Diba? It should be positive, and also it's possible pud na negative. Diba? Negative 5 times negative 5, then the other negative 5 times negative 5, nope, that is positive. So Our R here is positive and negative 5. So duha tong value sa atong R, no? Take note, no? R to the power of 4 man na, no? Meaning ana ang diri sa sulod is pwede siya negative, pwede pud siya positive. Okay? Let's proceed to our number example 4. Okay, so give the number of terms in a sequence whose a sub n is 324, a sub 1 is 4, and r is 3. Okay, so we'll just use the same formula. Here the unknown is n. Okay, so our a sub n is 324, our a sub 1 is 4, and r is 3. Okay, so let's have a substitute. That is 324 equals a sub 1 is 4, then r is 3. Okay, then n is unknown, so n minus 1. So 324 equals 4 times 3 is 12, right? Oh, sorry. Okay, sorry. Okay, again. Okay, so that is 4. Okay, this is 4. 3 to the power of n minus 1. So we need to eliminate 4 here. So we need to divide both sides by 4. Okay, so that is 324. Divide 4, that is 81. Then 3 raised to n minus 1. Okay, so what should we do to find n? Okay, no? So our goal here is that it should be they have the same base, no? Dapat kung 3 ni dire dapat 3 po diri sa ubos, no? Ato ni himuong exponential, no? Ato ning himong exponent. We'll express 81 as exponent. No, unsa pa express nimo ana as exponent? Okay? So that is 3 raised to 4, right? Okay, 3 times 3 times 3 times 3 is 81. Then 3 to the power of n minus 1. So by that, no, we can solve for n, no? We will solve the exponent since they have the same base naman, no? They have the same base, so atong isolve na yung exponent. So that is, so 4 equals n minus 1. Ang exponent na itong isolve. Then, we're going to transpose. Hindi na tasumpay, no? So, we're going to transpose that, the negative 1. So, it will become 4 plus 1 equals n. So, our n here is 5. Okay? So, therefore, there are 5 terms, no? The fifth term is 324. Okay? Next. You know? So, the same with arithmetic, they have arithmetic mean. So, the same, no? We have also geometric mean for geometric sequence. So, let's define geometric mean. So, geometric means are numbers between any two given terms of a geometric sequence. So, for example, in the sequence 1, 2, 4, 8, 16, 32, the numbers 1 and 32 are what we call geometric extremes. No, again, 1 and 32 are called geometric extremes, while 2, 4, 8, and 16 are the geometric means. Okay, again, these are geometric means. Again, this 1 and 32 are what we call geometric extremes. The 2, 4, 8, 16 are the geometric means. So, in other terms, no, geometric means are the terms, no, between any two non-consecutive terms in a geometric sequence, meaning na sa tunga. Okay? So, insert two geometric means between 5 and 135. Okay, let's solve number 1. So for number 1, so insert two geometric means between 5 and 135. So we have 5. We need to insert 2. So 1, 2, and our last number is 135. Okay, so the same, we will use the formula for the nth term of a geometric sequence. E sub n equals a sub 1 r to the power of n minus 1. And then, so how many terms? 1, 2, 3, 4. So that is a sub 4, right? A sub 4. So a sub 1 is, our first term is 5. R, how many terms? There are 1, 2, 3, 4. That is 4 minus 1. A sub 4, or the last term, is 135. So that is 5 r to the power of 3. Then divide both sides by 5 to get r. So r cube, what is 135 divided 5? That is 27. So the same no sa atong example kaganina, to get the r, since this is r cube, so we need to find the cube root, no? Since this is r to the power of 3, so cube root. So our r here is 3. Okay, it's only positive 3 because dili pwede negative kay since this is odd, no? Dapat kung odd ni isa ra ang value sa r. Pero kung even na, that is plus and minus. Okay, take note, no? Is this our final answer? Okay, very good, no? Dili na atong final answer. Don't forget, we need to solve the two geometric means. So since our r is 3, diba, we need to multiply to get the next term by our common ratio. So 5 times 3, that is 15. Okay? Then times 3, what is 15 times 3? Okay, the 15 times 3 is times 3 is 45. Then 45 times 3 is 135. So therefore, our two geometric means between 5 and 135 are 15 and 45. Okay? So let's proceed now to our number 2. So for number 2, find three geometric means between negative 2 and negative 162. So negative 2, we need to insert 3. 1, 2, 3. Then negative 162. So the same. So our a sub n, same formula, a sub 1. So in solving for geometric means, we just find the, pakitaon lang nato ang common ratio. So r n minus 1. So how many terms? 1, 2, 3, 4, 5. So this is a sub 5. So a sub 1 is negative 2. R is unknown. N is how many terms? There are 5. So 5 minus 1. So a sub 5 is negative 162. So this is negative 2 r to the power of 4. Then to eliminate negative 2 here, so we need to divide both sides by negative 2. Okay, so r to the power of 4. What is negative 162 divide negative 2? Okay, that is 81. Okay, so next is you need to find the fourth root. No, fourth root of 81. Again, this is even, no, so it should be duha atong value sa r. So r is, so find a number, no, that if you're going to multiply by itself 4 times, the result is 81. Okay, that is 3, no, that is positive and negative 3. Okay, pwede ba negative 3 times negative 3 times negative 3 times negative 3 is positive 81. So duha atong value sa r. Okay, so naapod tayo mga possibility, no, sa atong geometric means. Okay, so I will erase the other side, no. Okay, so Magdugay man ta maka-erase. So let's proceed, no? So if dili ta sa kilid. Okay, so if our r is positive 3, no, r positive 3, so that is negative 2. Negative 2 times positive 3, that is negative 6, no? Kung ang r, if r is 3, no, negative 2 times positive 3 is negative 6 times 3 pa gyud, that is negative 18 times 3, that is negative 54, no, times negative times 3 is negative 162, no? So therefore our 3 geometric means if r is 3, that is negative r, negative 6, negative 18, and negative 54. So what if r is negative 3? So if r is negative 3, that is negative 2 times negative 3, that is positive 6 times negative 3, that is negative 18 times negative 3, that is positive 54 times negative 3 is negative 162. So if r is negative 3, our geometric means are negative 6, positive 6, sorry, negative 18, and 54. Okay? So the geometric means are negative 6, negative 18, negative 54, or 6, negative 18, and 54. Okay? So what I have learned, so what we have learned now, the formula for finding the nth term of a geometric sequence is given by a sub n equals a sub 1 r to the power of n minus 1. Okay, so where a sub 1 is the first term, a sub n is the nth term, r is the common ratio, and n is the number of terms. So geometric mean is a number between any two given terms of a geometric sequence. Okay, so for your activity, so you need to answer what I can do. Letter A, numbers 2, 4, 6, 8. No, again 2, 4, 6, 8, the even numbers on page 11. So you will answer only number 2, number 4, number 6, and number 8. Okay, so next is letter B, numbers 1, 3, 5, 7 on page 12. Again, 1, 3, 5, and 7 on page 12. Okay, next. Yes, we are done with our module 4. See you in our module 5. Thank you so much.